Namaskara. In today's video, let us look at the methods of teaching the concept of fractions in an enjoyable and joyful way, and also look at how the teachers should teach and how children should learn it. The objective of this video is clarity of the concept and procedural fluency. How can both these objectives be brought about in children is what we look into. They should have learnt this concept before their fifth grade. According to NCERT, the dimensions of the fractions concept that are to be learnt by the children are as follows. Generally, why is the concept of fractions considered a tough one for children to understand? There are two reasons for this. The children might not have understood the division lesson well. That is, if they are given a division problem to be solved and the tables appear in their mind, trying to do division without knowing how to do it. One more thing is not understanding the language of fractions. That is, if I use words like denominator, numerator, etc., without them knowing the language of fractions, children will not get the concept of fractions. They will get into a completely different concept. Now, let us look at the outline or the framework that the teachers have to follow while teaching the concept of fractions. Fraction is nothing but a continuation of the division concept. That is, if I have to learn the fractions concept well, I should have a deep understanding of division. One more important aspect is the language of fractions. If this terminology is not learnt well, or if one is not able to express correctly in the language of fractions, children will find it extremely difficult. And fractions need not be taught in one particular method. We can use various methods to teach this concept. When we learn fractions, we divide a given object into equal parts. Meaning, in fractions, the term dividing, the word dividing means dividing in equal portions. For example, if a slab or a glass or a mirror falls down and breaks into pieces, it gets divided, but it is not divided equally. When we divide a full object in equal quantity, those equal divisions are the variants of that complete object or fraction. You can choose to teach fractions using the division method as well. Because as teachers, it is very important for us to understand if the children have a good knowledge of the division lesson, then it will be easy for them. Another point is fractions need not always be done with one full object. It can be done with a group of objects as well. From this group of 20 blue rings, if I take 3 away, that is, I have taken 3 away from this entire group of 20. That is, I can draw a variant even from a pile or group. Now, these are already divided from the group, but it is a part of the whole group. I have taken 5 from 20. This is also a fraction. To teach this concept, let us look at the TLMs that are suitable in our maths kit. For the first example, these are abacus rings. There are 20 rings each in 4 colors. With the help of these, we can look at the method of presenting fractions in a group or a quantity. Secondly, we can use these yellow cubes to show fractions in a group. Third, we will use this number line. Even in this, if we take it as a group of 10, you can say I'm taking 3 away from a group of 10 and show the fractions. Similarly, we can use these 50 counters to show fractions. Now let us look at the most favorite TLM for teachers and children. This is by making use of shapes, meaning dividing a square into half, making 4 equal divisions of it, or making 3 equal divisions of it, or in similar ways. How can a shape which is a full object be taken and divided is what we will see. This is a square and this is a circle. A circle is also a full object, and this could also be divided into half, three quarters, and quarters. We can use these as well. Apart from these, when we have to introduce the fraction numbers to children, we make use of these fraction strips. This is what they look like. This is one full object made into fractions. These are fraction strips. Similarly, if you have to teach the concept of fractions to children using a pile or group of things, you can use these squares, which are 100 in number. This is from the decimal set. We can use to teach fractions. Let us look at the method of teaching concept of fractions to children using TLMs at the concrete stage. We will now be taking this full object to teach fractions. I will dip it in water and stick it here. What shape is this? This is a square, correct? This shape, I will now divide it into two equal parts. It is important to divide it into equal parts. Remember that. But how can you believe that these two halves are from the same object? Let us place these two on this one. Is it a full part? Yes. This full object is divided into two equal parts. That is, how many equal divisions have we made? This one part and this is the second part. If I give this piece to you, we can ask the student, what will you get if I give this to you? When we divide the full object into two equal portions and hand over one to you, you get one. That is, what you have is one portion or one of the two equal parts. In what other way can we make equal portions? Can we make equal portions in this way? Can I cut it this way? When I cut it this way, I got these two. Can I cut it this way? Let us check whether it is equal or not. It is two parts of the same object. I will place them here. So therefore, this portion one of the two portions. If I give you one portion, how much did I give you? I gave you one of the two. Similarly, if I make four pieces of the same object, I can make four pieces like this. With the same full object, I will make that into four equal parts. That is important. When we teach fractions, we have to show that these are equal parts. It is the same full object. We can check that. Put it on the original object. We can verify it this way. It is correct. These four pieces can be kept here. I'll push it up here. Therefore, the same full object can be cut into four pieces in this way and that way. There is one more way. This one full object has been cut into four parts in this way, and this way. They are all equal parts. If I cut it diagonally, I get it like this. And in a different way, I get different shapes, as we can see here. So, this way, one full object can be split into different portions. Now, look at these three equal parts. Now, these three pieces and these two pieces, we have made two pieces here, or we can cut it horizontally also. Let us think about my birthday cake. I can cut it this way or that way. Both will be equal portions. So, in any way, equal, right? Same with this too. You look at it anyway, you will still get the same half. It's the same here. You can turn it, you will get the same portions. Here is a question. These are two equal parts of this object. These are the four equal parts of the same full object. If I give you one of that, it will be one of four. If I give you one of this, it will be one of two. From here, if I give you one, it will be one of three. So, this is what I know now. With one full object, I can cut it into equal portions, and if I give it to someone, then that portion can be expressed in this way. This particular piece, we call it 1 in 4. This is also called 1 in 4. This is also 1 in 4. That is, all these four parts have come from the same full object. So, if I ask, is this 1/4 equal to the other 1/4? Is it equal? How would you answer? All these 1/4s are equal to each other. Similarly, is this half equal to this half? See here, if this is a cake, irrespective of me cutting it like this or this way, I'll be getting half a portion of the same cake. Similarly, if I cut the cake into four pieces, I will still get one fourth portion of the same cake. So, tell me, how will you make the children aware of this? We will have to keep in mind just one rule. That is, if I have one full object and I divide it in equal quantities, then the equal portion of the full object, irrespective of how I have split it, what I will get is a one fourth portion or half portion of the same object. Sometimes there is a possibility of children saying, no, this shape is different, this is different, and this one is different. And looking at this one, I feel I might get a bigger piece. That is what the child may think. That is the imagination. But how can we explain this mathematically to them? In such situations, the matter that the teachers have to remember is we can use area, the concept of area, to diminish the confusion in children. But in primary stage, from 1 to 5th grades, the area of a triangle wouldn't have been started yet. Therefore, we are still not aware of the area concept, area of triangle. It has not been taught, so it is not advisable to give examples of the area to children from 1st to 5th. But if the statement, the area of all these is equal, is told to them, it will be a lot more easy for them to understand in higher grades. So, the important thing to remember here is the quarters of one full object are always equal, and the halves of the full object, irrespective of the pattern it is cut in, will always be equal and will not change. So now, keeping the same shape in mind, let us pick up a different shape. As we have already seen the halves and quarters of this one, let us learn with this shape now. What shape is this? This is a circle. Can I divide this circle into two pieces? Yes, we can. You can place these two halves on this one and examine if this is correct. Yes, this is the same as that one. Therefore, these two portions are the same equal divisions of this full circle. Can I make three equal divisions of this one? Yes, here they are. I can divide the same into four equal portions. Here are four equal divisions. You can recheck if these are the equal divisions of the same full circle. Yes, the same circle is divided into four portions, four equal portions. So, even in this, if I give one part away, it will be one equal part or half. If one of these is given, it is one of the four or quarter. So, in this way, you can use the terms like half and quarter while explaining. That is, what are these called? How many am I left with if I give you the quarter portion? And what remains with me? I am left with three equal parts of four, or the terminology is three quarters, is what we call. So, quarter, half, three quarter, and this is one full. Let us now split this full circle into 10 equal divisions. The same circle has been divided into 10 equal portions. If you give me 3 from this, it means 3 out of 10. Or out of 10 equal portions, 3 portions have been given to me. This one full object, this is the half, this is the other half. These are the quarters, quarter, quarter, quarter. This full object has these as the halves, and these are 1 of 2. This is 1 quarter, 1 of 4. That is, this is also called half, and this is also called half. Is this half equal to this? We had asked this earlier as well. Is this half equal to this half? What answer did we get? Yes, we had this full object which was split into two halves. We placed these here and rechecked and concluded that. Hence, this half is equal to this half. In higher grades, we can use the concept of area and verify it. Here, we have made two equal divisions of one single full object, is something we have derived. So then, what is the difference between this half and this half? Are these equal or different? The answer is this half is the half of this, and this half is the half of this object. We call it half in our normal dialect, but this is one of the two halves of the full object, and this is the half of this object. So, therefore, is this quarter and this quarter equal? This is a quarter or one equal portion of 4, and this quarter, is it equal? Is this 1/4 equal to that one? It is not possible, because this is a part of this object and this is a part of the circle here. Now, let us take this shape. We have just taken a shape at random. What shape is this? This is a rectangle. Is it possible to split this rectangle shape into two halves, equal halves? Yes. For this shape, for this portion, what name can we give? This portion is this one half of this portion? This white square is the half of the yellow rectangle. Therefore, can I place it here? It is 1/4. Here it is half. This is what we say. That is, in all these quantities like half, quarter, one equal part, two equal parts, the source object from which they are taken is very important. When children look at a pattern like this becomes a quarter when taken from this. And when it is arranged in a different pattern, both these portions become the halves of this object. We are taking this and not this as a one full object. And when we divide this full object equally, when we get these halves. Many times, what happens? Children as well as teachers also fall into a confusion of how can this and this be equal. We have to develop a capacity to understand the mathematization process quickly, and should know by applying which formula in mathematics can we get the accurate point or the correct answer. How do we get the right answer? So, we have to calculate the area of these measures to get an accurate answer. Hence, while using these methods in the concrete stage, the base object is important. When we keep the shapes as the base and teach the concept of fractions to children, when we make use of such different shapes, the idea of half and why these halves cannot be equal, or why are these quarters equal, why is one of four portion equal, all these being important aspects when taught along with the shape for fractions method will be useful for the children and they will understand it better. Similarly, when we teach the concept of fractions keeping the shapes as the base, children will have a clear understanding of the concept. So far, we have seen the method of depicting fractions with the use of shapes. Now, let us look at fractional numbers. Now, we have one full object. Since we are moving on to fractional numbers, if we have to represent the fractions in numbers and digits, we can take an example. This is one full object. What should I be doing with this? I should show it as a fraction. I'm now splitting this into two portions. When we divide into two, we have seen the fractions using shapes. What would we call them? 1 of 2, or I made two parts and gave one part. Now, if I give this to a student and ask, how many portions have I given you? The student has to ask a question even before answering. Sir, how many equal portions have you divided this into? So, I have made two equal divisions in this. Hence, you get 1 of 2, 1 half. Let us take a look at how many equal parts can be made. We can make it into 3 parts. Got it? These 3 equal parts have to be equal to this full portion. Only then we call it equally divided. In the same way now, how many equal divisions have we made? 1, 2, 3, 4. So now, how many equal portions are there? Let us see. 5 equal parts, correct? That is, what can we call these? 1 of 5. 2 would be 2 of 5 once and 2 times. So, I have given 2 of 5. How many equal divisions have I made this into? Even here, we are splitting this one full object into equal divisions. Therefore, I have made it into 6 equal divisions. So, we can call this one portion 1 of 6. These 3 can be called half. Next, I have divided this into 7 equal portions. And make it into 8 equal divisions. These are 9 equal portions and 10 equal portions. That is, this single full object is divided into 2 portions, 3 equal portions, 5 equal portions, 6, 7, 8, 9, and 10 equal portions. Through this, we can clearly understand the method of writing fractions. Therefore, if I ask the children, which one is greater, 1 of 2 or 1 of 8? In the concrete stage, children will hold this one equal part of 2 and one equal part of 8. Then they will understand that 1 of 2 is much bigger than 1 of 8. When I write the same fraction on the board, what would they think? They would probably look at only the whole numbers 2 and 8. They might not look at these as fractional numbers. That is why, in the concrete stage, the children have to follow the look and feel method to understand that 1 of 2 is greater than 1 of 8. Following the same method to bring about awareness, which is smaller, which is greater, this TLM is very helpful. If we arrange it in this pattern, children become aware of the meaning of this. If we arrange it this way, they will know descending order. This is 1 of 8 is smaller than 1 of 2. Not just comparing 1 of 2 and 1 of 8. You can also compare if 1 of 9 is greater or less than 1 of 10. When we say concrete stage, we can touch it, we can feel it, and then I can analyze it that this is bigger. So, when we write these fractional numbers, that is, we split this one single object, hence, this should not be considered as a fraction problem because this is a concrete stage, a method of play. Play and learn, do and understand. So, they are playing with these along with the learning about these and analyzing that this is correct. As this has been split into 2, this has been split into 3 equal portions, and similarly, it is divided into 10 equal portions. Therefore, if I pick out 2 of these 1/4 and pick out 1/2, are these equal? This knowledge can also be imparted. That is the way of doing it. What will happen if we join this to 1/8? It's right. If I have 4 1/8s, if I join them, I get 1/2 portion. That is, this half is equal to 4 portions of 1/8. Similarly, we can check this out. This is 1/10. If I take 1, 2, 3, 4, 5 1/10s, it will be equal to 1/2. What do we call this? Equal fractions. These are called equal fractions. 1/2 is equal to 2 quarters. 1/2 is equal to 4 1/8. This 1/4 is equal to 2 of 1/8, or 2 1/8 is equal to, can we say 1/10, 3 of 1/10 are equal to 2 of 1/8? Can we say they are equal? They are not equal. So, even here, it is not equal. 3 1/10s are not equal to 2 1/8s. I don't need to know the depths of mathematics to get into this inequality. It is very simple to understand in the concrete stage. 2 1/8s is not equal to 3 1 of tens or even 2 1 of tens, but others are equal. 1 of fourth is equal to 2 1 of eighths. We can see here 2 1 of eighths are equal to 1 4. So this way we can teach about equal fractions to the children. With this technique, the children can learn about fractions based on shapes as well as fractions based on numbers, and they can learn to compare it. They can learn the art of comparison. The same thing can be shown in this way also. We have already seen this. 1 half is equal to 2 quarters. When does it become a quarter? The full object gets split into quarters. When I divide a circle into 4 equal parts, the half of this circle will be equal to 2 quarters. One full object, half of it is equal to 2 quarters. This is a quarter and a half circle. That is what we are showing here. 2 quarters are equal to 1 half. 2 quarters are equal to 1 half. This is exactly what we are showing here. We have shown this with the shapes here. This is from the shapes point of view. This is in numbers. Now, the language of fraction. 1 of 9. I have 2 of them. I have the third one here. 3 1 nines. So, together I can call it 3 nines. This is what we can say. This is, in one way, it is the addition of fractions. The addition of fraction is not taught at the primary stage. It is not included in the syllabus. But this language, the 1 nines, I have 3 of them, and that is 3 of nines. There is nothing wrong. So, when we look at this, let us look at this activity. 1 thirds. What is the equivalent fraction? 1 by 3, what is it equal to? What can we join to get the same number? Now, I have given one example. If we join 2 objects, what becomes equal? So, we can tell them, we can give them more activities by giving them more examples. So far, we have seen the method of making fractions from a full object, right? We have looked at various examples to teach children the methods of dividing or splitting a square or a circle into equal portions to derive a factor. We have seen this so far. Now, let us look at the method of deriving fractions from a given group of objects or a pile of objects. To begin with, let us take this very familiar TLM. I will select one pile from it. This contains 10 beads. If I give you 3 out of these 10, how much have I given you? Here, you have to be very careful while using the language or the terminology. Here, I have given you 3 out of 10. there is a possibility of children making a mistake here and saying, I got 3. When you are teaching the concept of fractions, how much did you get? I say, out of the 10, I got 3. In the same way, if I give you 10, how many were in the pile? There were 100 in the pile. And from the pile of 100, I gave you 10. In the same way, if I give you 20 to a student, if I give these 20, should I be saying, I have taken 20 beads? No, I should say, from 100 beads, I have taken 20 beads. Similarly, 1, 2, 3, 4, 5. These are 50 beads. What is 50? It is the half. There are 100 beads and they have been divided equally. From this pile, if I give you 50 beads, from this group of 100, I have given you 50. How are these beads looking now? They are equals. That is, from this pile of 100, I have given you exact half portion. That is 50 out of 100. So, to tell you precisely, I have given you half of the pile from the full pile. Using the same method, how can you derive the fractional numbers from this group or pile? It can be done when I divide each of these things or when I distribute it equally and I give one of the portions to you. This is that any group that I choose to give you, that group is given to you only after the entire pile has been divided equally. This is an important point. Similarly, to give one more example or idea, we can use these yellow cubes also. It is always better to give examples close to everyday life activity. For example, I work at a shop and we sell geometry boxes. In that shop, the school is starting now, and the boss asked me to go and check how many geometry boxes are there. Let us consider that one type of geometry box is for primary school and another type of box is for high school. They have two different types of geometry boxes. So, totally there are 100 geometry boxes. How many geometry boxes are there for the primary school? We can take it as 50 in 100. Or how many ever are assigned, like 25 in 100 or 30 or 100. So, in the available stock, how much is assigned to the primary school? So, in this way, if we take such examples, the method of deriving fractions from a group can be taught easily. Moving ahead, let us put these yellow cubes away and take this group of 50 square counters. When I ask in this pile of square counters, how many blue square counters are there? The children will start counting and pick out the 10 square counters. So, if I give you these blue colored counters from this pile of 50 square counters, how much would I have given you? From the pile of 50, I have given you 10. Similarly, the yellow cubes, from the pile of 50, you get 10. So, how much of how much is given? This kind of terminology is very important. This is one aspect that has to be put deeply into the children's mind while teaching this particular topic. Why do we have to lay so much emphasis on this aspect is that when we learn to derive fractions from a group or pile, it will be very helpful in future to learn different concepts for the children. More concepts are introduced in higher grades like the 6th, 7th, and 8th and include topics like percentage, decimals, or ratio, or graph depictions. So, for all these concepts, the fractions in groups will prove to be very helpful. So far, we have seen the concrete stage of fractions by using fractional strips, fraction numbers, and fractions in groups. Before moving on to the abstract stage from the concrete stage, let us look at the methods of showing fractions in a representational stage or a pictorial stage using a square line book. To begin with, in a square line book, I will draw boundaries to these four squares, meaning these four squares have a blue boundary around them. Now, I will color one of the four squares with red. So, tell me how many squares have red color? The language becomes very important here. Out of four squares, one has been colored red. There is an important point to be remembered. You should not say, I have colored one square. You should mention that out of four squares, I have colored one square. Similarly, I have drawn a boundary around these 10 squares. In that, I have drawn a line between every two squares. I will color this portion, that is, out of five portions, I have colored one portion. So, this is how I can show one of five. In the previous example, out of four equal parts, I have colored one division. Let us look at one more picture. One, two, three, four, 5, 6, 7, 8, 9, 10. 10 equal portions. In these 10 equal parts, how many parts have I colored? 1, 2, 3. But how many equal parts are there totally? There are 10. So 3 parts have been colored. As you can see here, while teaching this concept to children in this video, the definition of this, that is the numerator and this is denominator, has to be taught to the children once the concept is imparted to them or understood by them clearly. That is the apt method of teaching. Since the concept of fraction is a tough one to learn already, it is a difficult one. Even before introducing the topic, if terms like denominator and numerator, if we fraction itself is a new word to them. If we start teaching them numerator and denominator, these are new words. I have learnt a new concept. There are so many words in it. I am unable to make out which is the numerator and which is the denominator. That is, while teaching a child, if you say, how many are here, how many did I color, how many did I give, and how many have I taken, and make use of some verbs or action words to make the children understand. And by telling them, I have received, or those are the colored ones, are written at the top, and total number of equal parts that are divided equally are written below. Let us look at the same method in another picture. This picture, from here to here, it is 10 squares, and from here to here, 10 squares. There is a total of 100 squares in this. In these 100, I will mark for these squares, I will put a color. I will fill up this particular area. What does it denote? Out of the given 100 squares, I have filled 25 squares with color. All these are various methods of depicting fractions while teaching children. So, here, if I draw a line, what are the groups? If I draw a line between the colored ones and the total number of equal parts, we can see 25 is the colored part and 100 is the total part. Even here, if we put a line here, this is the colored one, this is the total one. This is the colored one, this is the total one. These are the equal portions, 2 each. There are 5 such portions. And here, every part which was divided equally, 3 of them were colored. Here, 100 parts were there, 100 equal parts, 25 were colored. So, this is how we can teach them the concept of fractions with the square line book. Now, let us look at it in another way. This is my single full object. Let us see what could be done with this full object. How can we learn about fractions in this, or how to depict the fractional numbers in this, is what we will see. This is one object. This is what I have taken as a full object, and I have only one of it. I can draw a line here and split this into 2 portions. This one portion can be called 1 of 2. This is also 1 by 2. With the same full object, how many parts are there now? 1, 2, 3, 4. 4 equal parts. So, this is 1 of the 4. How many do we have in total? 1, 2, 3, 4. So, one part is 1 of 4. Therefore, this is 1 of 4 equal parts. This is also 1 by 4. Every portion is 1 portion. If you add them all, you will get one full object. Let us do it. Let us continue. Here I have made 1, 2, 3, 4, 5, 6, 7, 8 equal parts. That is, each one is a division. This is 1 by 8. What will happen when all these are combined? 4 equal parts. But of how many? Out of 8. So, 4 in 8 equal parts. That is 4 in 8 is equal to this half. We have seen this while using the fraction strips. This is a way of depicting the lesson that I have learnt using the square line book. If I do not make use of the fraction strips, this is a stage of explanation where the teachers help the children to use the knowledge procured in the concrete stage for depicting the fractions using a square line book in the absence of the fractional strips is what we see here. This is a special technique. If the children succeed in doing this, that is, they have understood the concept well. So here we have 1/8 of equal parts. How many equal parts are here? Half of this is, we have made 16 equal parts here, and we call these 1 of 16. 1 by 16. So, these are the methods we follow to bring an awareness in children about using square line book to depict fractions. That is, we are trying to achieve clarity of concept in children using these techniques. Let us look at the ways to adopt this in everyday life. What do we call these in our normal language? We call this half, and this is a quarter. In the fraction terminology, 1 out of 2. We call it 1 by 2. This is 1 by 4. 1 by 2 and 1 by 4, 1 by 8, 1 by 16. If we take 2 of these, it would become 2 of 4. This would be 1 of 2. If we add 1 by 2 and 1 by 2, we get this 1. What full object we started with, we get the whole thing back. We can see that in every segment, 1 by 4, 1 by 4, 1 by 4, 1 by 4. If you add them, you get one full object. That is, 4 of the 1 by 4 is 1. We have seen this earlier. This is a rule of the division also. Let us look at how to use fractions in our everyday lives. There are 50 students in my school. Out of the 50, 25 are girls. So then, if I have to tell the number of girls in my school in fraction, how do I do that? The answer is whole of 50 is split into 2, meaning 25 plus 25 is 50. That is, when I divide 50 into 2 portions, one portion is that of the girls, meaning girls form half the portion. If we have to depict the same without using the words like half, quarter, we can say it differently. 234 students came to our school to take up the 10th grade exam. 89 students were from our village. Therefore, how many were from our village? Out of 234, 89 children were from our village. This is also a fraction. Most of the time, we depict fractions as 1 of the 10 equal portions or similar examples. But in everyday life, fractions could be depicted in this way also. Another example, the cost of the school bag is 100 rupees. But today, it has a half price discount. You will get this bag for half the price. There is a fraction here as well. How much is half of 100? Why have they mentioned it as half here? The store might have a half price discount on many items, but we have to take into account the price of this object and calculate the half of that. So, this is another method of looking at fractions in everyday life. This is an important aspect. Now, I will take another example. Went to the market along with my family and bought 12 clothes. 3 clothes are for me, 3 for my sister, 3 for my father, and 4 clothes for my mother. So, if in 12 clothes, 4 are for my mother, what is the portion my mother has received? How can this be depicted in fractions? Answer is out of 12, it is 4. 4 by 12 means it is one third of the lot. In another example, mother had given me 5 jobs. In that, I have finished 3. How many more are remaining? Out of the 5 works, I have 2 remaining. In this way, if we go on using fractions in our everyday lives, there are possibilities of children grasping much more knowledge about fractions than expected or necessary in the primary teaching. Take, for example, I have half a circle with me. If I combine 5 half circles, how many circles will we get? You can find out the answer for this. Draw a circle, make a half of it. If there are 5 of similar halves, how many circles did we get? So you can find out the answer for this. Now let us look at the ways in which or reasons which create a misconception or misunderstanding about fractions. Let us see that. Firstly, what misconceptions might the teachers have during this lesson sometimes is what we'll be looking at. To begin with, should the concept of factors always be taught keeping in mind the one full object has to be considered as the basis for teaching the children, or should we use heaps or groups to depict fractions? Apart from that, how can the language of fractions be taught to the children? This is very important. Without understanding the importance of these basics, if you are teaching how to read the fractional names or trying to teach its definition to the children, introducing the language or terminology to the children even before they understand the basics, it will be difficult. And many times, apart from the primary knowledge of fractions, teaching the different types of fractions like improper or mixed fractions will lead to a misconception very often. When does a misconception occur in a child? When it comes to not knowing about the numerator or denominator. What is the necessity for fractions in everyday life? Where is it useful? In everyday life. In real life, not knowing about this, meaning without giving a real life example or without mathematizing it, teaching it is the wrong way. One more area is comparing the fractions, because numbers are in a different way. Fractional numbers are in a different way. When children look at the fractions, the number lesson comes to their mind. it is difficult for them to absorb that fractions have different types of numbers. So they don't think about it. When you compare 1 by 8 and 1 by 2, which is bigger, they will have a quick answer that 1 by 8 is greater because 8 is greater than 2. But when the concept like how many equal portions did you make of the object to take one from it is not understood and the comparison is made. This is a mistake. Similarly, children often get confused when it comes to addition or subtraction of fractions. There is a difference between adding and subtracting to normal numbers and adding and subtracting the fractional numbers. If this is not understood, all these misconceptions and misinterpretations occur. So, then how do we correct these misconceptions and misinterpretations from the children's minds? First, how do we get rid of these misconceptions? In the concrete stage, children have to make use of the objects, understand the concept. Later, they should practice the same in a square line book in the representational stage. The memory that they have from playing with the concrete objects has to be used in the square line book, as they will not have the concrete objects while having the square line books. They will have the books only if they have a memory of playing with the concrete objects and show the same in the square line book. Then they have understood the concept clearly. So, if these aspects are clarified in the classroom, all the misconceptions and misinterpretations will reduce. So far, we have seen how the concept of fractions could be taken from the concrete stage to the abstract stage through representational stage in a joyful and enjoyable method of teaching in a classroom. This is what we have seen. Hope you will all practice it. Thank you.